And it's just going to be loading CSVs. Okay. So, all right. So let's continue here with this Jupyter so I don't have to create a new one. I'm going to do, call this one load CSV. CSV. And I like with everything, there's many approaches. This is just one of many. Okay. So we're going to load our wine data into once again, a torch tensor. That is the objective. So I'm going to use a library called CSV for this one. Import CSV. Let's see if this one is installed already. It is, right? So it is already, so we don't have to do any installation. So now let's go ahead and specify the path to this file. So I'm going to do wine path equal data / and the file is wine quality dash white dot CSV. Okay, so that's our file. Just going to read it. So in this case, we are going to use Numpy. Later on, we will learn how to use pandas, which is extremely powerful. And we'll do some nice tricks with it. But let's just start here. So wine. Now this is going to be now the NumPy tensor. So I'm going to call it wine Q NumPy, just to be very clear of what it is. And I'm going to invoke NP. So that's NumPy, right? NumPy. And so NumPy has a function called loadtxt. Okay. So I can just use loadtxt. And that's it. So now I just need to specify the wine path itself, comma, and then we want to tell it what data type, because we're creating a NumPy array, right, as it's reading it in. So this data has decimals, so then we can use dtype equal np dot float. Oops, not float. Float 32 here. If you notice, before we did something like torch dot float and now it's np dot float, you see how they copy each other? They're not always the same, but they do have the same like logic, the way of thinking. All right, so that's going to be the data type. What else do we need? We need to know what the data looks like in that file. So let's go in. So the file is this one. Okay, there it is. That's your data. What do you have? You have a header with the names of the columns. The data is separated by what? Semicolon, right? So that's called the delimiter. We need to specify that. By default, the NP function will probably think it will be a comma. So we need to specify that. Make sense? Now, with pandas, it's really nice to use pandas because you get to load everything, including the titles of the columns. All right. And then you can actually do searches and things like that. And like, if you guys know like databases and that, you can do almost like database operations or Excel operations in pandas. NumPy can only wants numbers, wants a tensor, right? So what we do is, if you notice, 1 is the first row, okay? So we're gonna, to load it into NumPy, we're gonna basically ignore the first row for this one. Later on, as I said, with pandas, we'll look at how it can be done in another way. Now, another thing that's important, just to get a feel for what's going on, let's just think of the data. So we've got fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates, alcohol, and quality. So what do you think this model will do if we built it? Yes, sir. Predict what that will be. Yes, exactly right. So basically, we would build a model that would predict quality. The quality probably seems to be this last number, so like quality 6. So I'm assuming it goes from 1 to 10 probably. I assume 10 is the best quality. And then, as you said, we can build a model. When we give it these inputs, it tells us quality. We can also say, okay, which of these factors are most important for determining quality, all that stuff, right? This is where we're going, right? Building models for this, doing all that analysis. It might be that we have multiple inputs, multiple outputs. So that's what's coming up. We may even use this data set for some of our problems in the future, okay? This is also what I said, start looking for regression data sets, all right? I will give you one homework where I just want you to do it on with your own data. But anyway, that's kind of where we're going. However, since we're only using NumPy, we're going to get rid of that first column for now. And so that way you could still do the model. You would just have to remember, right? Okay, this column is for this, by index, basically. All right. But anyway, so our goal for now is just to load this data into a torch tensor. So I'm going to go, now that we know all this, I'm going to go back to my function and I'm going to say that what the delimiter is. So the delimiter is equal to semicolon, right? That's what you guys said. And then also we need to skip one row. The first one. So skip rows equal 1. Got it? All right. So now this should load my NumPy array. So and that's it. I mean, I'm not gonna do much else except to kind of conclude with my X and Y, right? So you guys remember that I gave you those word problems where I always asked you what is X and what is Y? Well, this is a data set that should also end up as X and Y as we move forward into modeling. So let's read it. Hopefully it won't break. So it didn't break. Y_Q Numpy is now a NumPy array, so we can print its shape. And this next question, like the previous ones were hard, right? But this one you guys should be able to do by now, okay? So I'm going to do print dot shape. All right, so what does that, how do you interpret that?
All columns, 1,000.
And what does that mean in terms of machine learning? Which ones are the features? All of them? All 12 are features? Yes, very good. So the last one, Y quality, is what you predict. So that's the Y vector. The first 11 are the features of X, and there are 4,898 samples. Remember, this is how you need to speak and think and talk, right? Because that tells you everything about the model, right? All right, so now let's go ahead and we'll conclude with this today. And this is something you should be able to solve yourself, right? I should, like on the exam, I could give you, I want you to slice that from Y_Q NumPy, slice out X and Y. Tell me, how do we do it? Oh, and another thing is, since I'm using NumPy here, right? I'm still in NumPy. Let's make it into a torch tensor. So because at the end of the day, our models are in torch. So that should be straightforward, right? So Y_Q equal, by now you should know this function. What is it? Torch dot from NumPy, right? Very good. From NumPy. And then we just give it Y_Q NumPy. Yeah, so remember that all our models are going to be pretty much torch. Okay, so now from Y_Q, I want you to give me X and Y, because now X and Y will be torch tensors. So how do you do it? Slice it. You start with what? Y and Q, right? Square brackets. Y and Q, square brackets. All right, so now, what are the values here? Huh? For the first one, 0. For X here? Yeah. Lucas. Well, remember how it works, right? I need the rows and the columns. Okay. Colon, comma, that's good. What does that mean? All the rows, right? Very good. And then what? 0? Yes, and you said colon 11. You're both saying the same thing, right? Very good. So yeah, so let's go with colon 11. Let's actually try to do it like that format, right? Got it, guys? Yeah. All right. Now, because of off by 1 errors, I always like to print the shapes because I may just miss 1 or something. I'm terrible at that, so I just print the shapes. Now, what about Y? Comma. Okay. Comma. Colon -1. Just, it's only 1 column that we need, right? Just okay. So let's say 11 or -1, right? But because of off by 1, let's get rid of that because it's only 1 column, right? The last one. So yeah, that looks about right to me, but check the shapes always. Because you know, I'm not sure, you know. Okay, so let's do that. Okay, 4898 by 11. Yeah, and there's 4898 by 12. So yeah, so we grab all the features. And then the last one should contain the qualities. You can also print it. So this should go all the values should be between 1 and 10. And yeah, see, they look like the actual quality values. Got it? Make sense? All right, very good. So this is actually, you know, what we need to do, right? So we read CSV files, then we slice it into X and Y. You need to master slicing. Master it. That's why I gave you those Numpy problems. Go back to them. Muscle memory, right? But in the end, as you become, and it'll take time, but as you become better and better with those things, your code gets shorter. Your code gets super efficient and faster. You know, and so it's better, right? So it's as you progress, I mean, it takes time, but definitely what it's not so much that I want you guys to be able to do all this stuff. It's that I want you to understand that it's important that you should want to do all this stuff. And you're self-motivated. All right, so that should conclude. Yeah, so this concludes these examples. All right, so it's 7:47. We'll stop here. We're still a little bit behind. We have to do the playing with the cat images and just show you one thing, but those are like very short things, so I'll throw those in. So I think